We're focusing on non-energies, although it is energies. We're focusing on energy efficiency and transportation. There's no question that the global demand and the drive, particularly in Asia, is stressing everything about vehicle transportation, from emissions to certainly energy consumption and all the problems of traffic and congestion. Our business model and our value proposition addresses this in a very dramatic way. There is a room for electrification, and we certainly understand it and support it, but it is a mature economy, rich world solution as far as we're concerned. And unless we're really going to address energy and emissions in the transportation industry in the next 3 or 4 decades, we have to address the 90% solution, not the 10% solution as well. And that is, how do you clean up the inherent inefficiencies of today's internal combustion engine? And when we said Tesla invented a motor technology 100 years ago, well, your internal combustion engine is almost as old. It took 25 years in Cummins. I studied diesels a lot and engine technologies and diesel and gas. So we all know have been there for quite some time, with lots of improvement. Basic architectures are the same. Pinnacle's addressing that. One busy slide, and I'm going to stay away from these, but how are we doing that? I mean, from an investor perspective, we heard lots of conversations the last day and a half about what do you take to get into conservative industries that are quite large, and I think we're addressing all of these questions with what we're trying to do with Pinnacle. First, it is a novel proprietary internal technology. We all talk about game-changing. This one is one of those as well. It's 50% improvement, up to 50 in terms of fuel economy and measurable emission reductions at today's traditional engine cost. So we can do hybrid-like efficiencies, tested and validated, and I'll try to explain that in a minute. Hybrid-like efficiency, advanced diesel-like efficiency without the cost. And for most of the world, that's a critical solution and a game changer. It's a huge industry. Andrew Jones talked today about a $300 billion industry that Eco-Motors was looking at. They're concentrating as a 2-stroke diesel, along with competitors they have at the high end of that market, which is the trucking industry. We're concentrating on the lightly loaded piece of the market, the 4-stroke gasoline marketplace, and everything from 2-wheelers to small cars and light commercial vehicles. But even that's a $120 billion industry. In Asia, growing, it's half the size of half that market and growing at a faster rate than nationally and globally. Look, you're entering a very conservative business, a very difficult business to enter. How are we going to do that? We're going to do it with an asset-light model, focus on integrated solutions that are principally around licensing. We'll license this technology to key OEMs and already have started. And the control systems around it, the brains and the brawn, because there's some unique features to how the engine operates that we can really build into our solutions around the electronic controls and bake that into the silicon rather than worry about making engines, which is just too capital intensive. When we looked at this technology, I was part of NEA as an advisor, said how do we get it introduced? And the best place to do it was in emerging economies and smaller vehicles where speed to market and acceptance of innovation is growing much more rapidly than in traditional markets. So we focused here in Asia, and we're developing all of our efforts in first-generation customer base in Asia. Most importantly, we have our first customer. It's a licensing agreement with the controls to follow with a major Indian manufacturer of 2 or 3 wheelers, 2 million or so right now, going to 4 million vehicles, and we're moving in with our technology, a joint development program by the end of 2013. It takes that long to go through the development cycle of the vehicle, but by the end of 2013, in one of their high runners, and I'll give you a slide or a picture of it in just a second. Behind that, we've got 16 customers, mostly through Asia, who are actively in conversations with us, some MOUs under discussion right now, across the spectrum, from 2-wheelers to LCVs to small cars, for similar agreements. And if you look at that probability-weighted revenue over a 10-year period of time, it's in the $1 billion range. So we're commercializing. It's no longer about giving somebody an engine to test in a lab or test in a vehicle. We're actually bringing it to market, but we are commercializing as a technology company with licensing. We've got some blue-chip investors that we talked about, NEA, Bessemer, and a great leadership team to go with it. Everybody has a great leadership team. We've got a lot of practical experience in the industry. It's a really interesting mix of race car engine technology, solid experience in large European companies, in and Indian companies in the transportation industry. And my background is both with NEA and then in the diesel engine industry, so I won't go into any more detail than that. We're multi-country, multicultural, and a terrific range of experience. I mentioned these three markets, the two-wheeler, light commercial vehicles, and cars. What's common about them in several ways, and you all know this, they're big. You can be in a two-wheeler, three-wheeler market, and it's a $13 billion engine market in and of itself. So don't think small when you think small vehicle. All of you know that. You're sitting in Asia. You can have these conversations with people in North America, and they don't get the size and scope of a two-wheeler market, three-wheeler market. Across the board, there's Asia. Asia is a critical component of all these markets. We're a couple leaders and below is where we're focusing. It's all driven by Asian, some other emerging economies as well, but principally it's Asia. And then there's a terrific opportunity for us that I haven't mentioned around alternate fuels. This engine runs fabulously as a clean engine on alternate fuels, especially natural gas, but biofuels and ethanol and the like, and we get incredible performance. That's where some of the 50+% improvements take place. In Asia, where alternative fuels are part of a transportation solution, we're going to be outstanding. How does it work? I am not the technologist. Everybody else is going to go into technology. I'm just going to show you a couple slides. Very simply describe this. This isn't a post-piston engine. That's been around for 100 years. Why? Post-piston engines in two-stroke diesels have been around because there's less heat loss in that combustion chamber. More heat is kept in that chamber because the volumetric surface area during combustion allows for less heat to dissipate. The problem if you're in a fixed geometry environment versus this expansion ratio here is you don't do anything with that heat except send it out the exhaust stack. Here we can keep it in, turn it into mechanical work with these post-piston and crankshaft systems. As I mentioned, a post-piston. What makes this work, though, the technology that has been patented effectively, is that no one put together a sleeve valve, which has been around as well in certain aircraft applications. No one had put together a four-stroke sleeve valve configuration before. And what that allows you to do with the four-stroke is to end up with some very and cooled systems of sleeve valves, very interesting combustion techniques, including 15-to-1 compression ratios, which also, when it's combined with these things, diesel-like compression at cool temperatures allows us to do, without knock, allows us to do some very incredible things in terms of the overall efficiency. So it is a systemic breakthrough in that regard, and this architecture in combination is all fully patented, which I'll describe. You see a single cylinder. We're getting those terrific benefits right now with this first engine we're developing for our commercial partner. There's nothing that stops this from being multi-cylinder in application as well, and getting in, depending upon your cylinder size and displacement, getting into, as they say, light commercial vehicles and small cars. In fact, when I looked at the 16 OEMs we're talking to, about half are two-wheeler, three-wheelers, but the other half are four-wheel, LCVs and car applications in Asia in particular. One more cut in technology, then into the commercialization. That's a kind of a cutaway of a traditional cylinder with a cylinder head, poppet valve arrangement, where a lot of cost is and a lot of the problems of heat and heat dissipation exist. We've eliminated that, and you can see in these to scale that we're looking at things that are about the same displacement, larger applications, even less displacement. It's equal power, equal displacement, equal packaging, much better fuel economy, and the materials are the same. There's nothing dramatic about it. Everybody who's in the manufacturing business of engines can do this quite well because it's the same pistons and connecting rods and crankcases that exist in the existing industry. So there's no point in us creating a new manufacturing capability that exists out there. So how are we doing? Well, we do have a customer, and that's really key. I want to talk about that in a minute. But we've also been validated in the industry. We've used their 3 major engine houses. Ricardo started the evaluation that got NEA involved. We've worked very closely with FEV, who is a major engine engineering, one of 3 in the world of automotive, if you know them, that's most respected. They have become our partner in validating their own test facilities in Detroit, 50% efficiency improvements. They've now become a partner who are sharing their excitement for the technology with us as we go into Indian and Chinese auto companies. They're coming with us, and they're really a credible partner for us because of their expertise. Then the SAE Congress in April in Detroit, certainly a leading automotive engineering Congress, voted us one of the 4 or 5 out of about 200 most exciting or best technologies of 2012. So we're beginning to get that kind of recognition, but the market validation is the biggest recognition. I've already talked about those two. Getting to market, doing it capital efficiently, and becoming profitable is the #1 key in this, and that's where we think we have a major head start. Just one example of the potential of this engine as we grow into the automotive is with FEV, who does a lot of benchmarking in this regard. They've taken a look at and done this evaluation of what the Honda Fit, a very good, efficient car, Honda engine, can do it. And it's in a city cycle about 36 miles per gallon or 16 kilometers per liter. You take the same engine that we have downsized, turbocharged with a variable compression ratio, which I'll talk about in a minute. Smaller package, we can do it, same or better power, 50+% improvement, no additional cost. So that's when I say the potential for us to do diesel-like and hybrid-like efficiencies at no cost premium is there, and validated, at least in these simulations right now, we can go make that happen. I want to mention variable compression ratio. If you know anything about automotive industry, that's a holy grail. If we're going to really dramatically improve fuel efficiency, the ability to vary compression ratios during various cycles, depending upon what your power needs are, would be a tremendous breakthrough. We're the only ones who can do it. It's the combination of the 4-stroke and the 2 crankshafts that allow us to do a phase change on a crank or a cam and change compression ratios. Lower compression ratios, highly boosted to get power when you need it, and you can run higher compression ratios, not boosted, to get the efficiency when you need it. And we can do this. We have a very simple patent underway, a process for doing that. I also mentioned on the right the multi-fuel operation capability across the spectrum. And we can move back and forth with a simple electronic switch. We're not talking about single fuels, we're talking about dual fuel. Eliminate the range anxiety for CNG users by having a small petrol capability to limp home with if you needed it without any battery requirements associated. 105 patents that are filed one way or another, including the most important that are granted globally in the full system application for this growing patent capability and controls and beyond. Our first customer, codename the TP90, it's, you know, a pretty simple little product. It's there in our test cell, same thing in India. It's just very nicely packaged in the scooter. Drives the fuel economy, it's miles per gallon from 110 to 140. A 30% improvement in fuel economy with perhaps a 2 to 3% increase in the cost of the vehicle. 10% on the engine max. This is a game changer in India, for those of you who know India, and a lot of other markets in Asia. And we're already underway with that program. As I said, it's going to launch at the end of 2013. I say we're commercializing through this partner, but it's the first of many such collaborations with them, and then we're going to move on to other partners. We're not a two-wheeler process. We're an engine platform in ultra efficiency for the future. So we have grand plans, and we will carry them out to move from single-cylinder versions to multi-cylinder versions, move into the full car market and a variety of light commercial vehicle opportunities. And this is a 3 or 4 year roadmap. It's going to be market demand and market driven. They're the ones we're going to focus in on. They'll determine at what pace we make those changes. And frankly, we have the technology now to move to a car, highly turbocharged, highly downsized version if we need it. Where we're going to concentrate our design and production and sale capability is on controls. The brains behind the system. And we have some unique spark timing, the variable compression ratio, some things we need to measure or want to measure that traditional architectures don't. So it's a different control. Now, we're not in the controls business. We've got a fair amount of controls design expertise. So we're going to start with a partner. Continental AG is that initial partner here in Singapore. We're going to develop this business capability in Singapore. We've already decided to do that. And then spread it through the rest of the world. Our focus will be on the design piece rather than the actual production, and Continental will lead that production charge. I don't need to go into the details of why that's important. I want to give you just a quick look at the strong pipeline of customers, two-wheeler, three-wheeler LCVs. All of those are part of a financial plan that there's a lot of detail here. I grabbed this off of a pitch we're doing for the investors. So the point being, we've got a simple, capital efficient way to get to market. We're generating revenues now. We'll continue to generate the profitability in 2014. We'll do all of that with this next round of funding, combined with our first round, no more than $30 million of capital spent to get to profitability in 2014 or 15. So it is the only way I see to really effectively, cost-effectively, where investors enter a market as complicated and as slow to adopt change as the automotive industry. But we figured out how to do it. We've already got that first partner and several more on the way. That's it. We've got, we think, the game-changing architecture for the future in internal combustion engines, which have to be addressed. We've got our first customer and a sizable customer, over $100 million in revenue in the next 10 years, and a pipeline that's going to generate a lot more than that. We've got an asset-light model and approach to make that happen. It's the only way we think you can actually get the profitability fast enough to have a reward for investors. We've got a talented technical team and business team with a lot of experience. We're continuing to grow and develop, and frankly, half of that team will grow in Asia, and a significant portion of it here in Singapore. We think we've got everything we need to enter the market and to continue in, for several decades to come, in an engine technology curve leadership position for internal combustion engines. I call it clean tech. It's cleaning up what we have today. The future transportation may not need fossil fuels, but that's certainly after I will depart from this world, and someone has to address the bridge, and we think we're doing it.